This video will give you an introduction to reading data in non-R formats. By the end of this video, you should know what type of data files you might encounter when using publicly accessible data, how you can load non-RDS files into R, and what additional information R might need when loading non-RDS data files. Up until this point, we've loaded data directly from RDS files. To do that, you use the readRDS function. But where did all these RDS files come from? Did I just download them off the internet? Is there a big RDS ranch somewhere in California? Every RDS file that we've used so far in class, I've created. I did this by downloading data from a public data repository, reading that data into R from the source file. These usually aren't RDS files. I wrangle the data into a useful format, and then I save the output as an RDS file. This is typical of the pre-processing step in the data science workflow. Most publicly available data on the internet is not in RDS format. RDS files can be read only by R, and that makes it difficult for non-R users to access data that's in the RDS format. If your goal with publicly posting data is to make it widely accessible, RDS is a bad choice because only R users will be able to access it. As a result, people frequently use other data formats. What I have here on the right is an example of some real-world data. Looking at this, how would you convert this information into a tidy dataset in R? What kind of decisions would you need to make ahead of time? What I showed you there was only one example. Real-world data come in countless formats. And when you're loading data into R, or any data analysis software, it needs to know what information constitutes a single observation, what variables are included, the data type of each variable, the names given to each variable, and the information within each observation that corresponds to a given variable. There's other considerations that may or may not come up. For example, is there information in the file that should be skipped or ignored? How should you handle missing variables or observations? And does the file use special codes to denote missing information? If you get the answer to any of those questions wrong, it's going to prevent you from faithfully reading a dataset into R. RDS files contain all the answers to these questions. Reading data into R from an RDS file is easy, and that's why we start with those. Other file formats build in answers to some or all of these questions. Sometimes those answers are less than ideal, and in fact, there's no one single best format for exchanging data. There are many file formats used for exchanging data, but some are very common. Probably the most common are text files. These are files of human-readable, but often difficult to parse text. They have standardized formats to delineate observations and variables. Some common examples include comma-separated value files. They usually have the CSV extension, tab-separated text, which might have a TXT or TSV extension, and fixed-width files. These may have many different extensions. There are other common text data interchange formats. Again, these files are usually going to be human-readable. There'll be text inside of them, but they'll also be difficult for you to read on your own and parse the data out of them. These other formats usually have rigid schema that include information on the observations, variables, variable names, data types, and much more. Common examples include XML and JSON files. Many of these data types can contain non-rectangular data, so you have to be very careful when you read them in. As an alternative to text, there are also binary formats for exchanging data. These are going to contain information in a computerized binary format, so if you open up the file, you won't be able to glean anything from it. They usually contain information in this binary format on observations, variables, variable names, data types, and possibly more. Common examples of binary file formats include Microsoft Excel, Stata, and SAS, which are both data analysis languages, and the older DBase3 files. In R, the tidyverse and other libraries provide many useful functions for reading these different types of data files. These are specially designed programs. They're going to do their best to try and answer all of the questions that you need to read in the data reliably. You're often going to have to provide some information, though. These functions will generally be named something along the lines of read underscore and then the type of file afterwards. Almost all of these readers also have a corresponding writer that has the name write underscore and then the same piece of text afterwards. These are going to allow you to write files in these formats as well. Base R also has file readers. They usually have the names like read dot and then something afterwards. I will exclusively use functions that are in the tidyverse and use the read underscore notation, and you should prefer the tidyverse version of these readers. But let me show you why. In this table, I compare some features and descriptions of the base R readers versus the tidyverse readers. Again, base R readers will have names like read dot something, whereas the tidyverse readers will have names like read underscore something. The base R readers are going to output data frames. The tidyverse versions will output tibbles, which are a superior version of the data frame. The base R readers are okay speed-wise. The tidyverse versions are much faster. In terms of ease of use, The base R readers are very poorly documented. The arguments that you provide them are inconsistent across different readers, and that generally means you have to read the manual every time. The tidyverse readers are designed to be consistent across all of the functions. Arguments perform in the same way and are specified the same across all of the functions. The tidyverse readers can also automatically decompress files that are compressed in the zip, gzip, or bz2 format. The tidyverse readers will also handle any type of variable name. Remember, Tibbles can have variable names that include any piece of arbitrary text, but if it's not a standard R variable name, it has to be enclosed in backticks. The tidyverse readers can accommodate this. The base R readers are going to mangle variable names, replacing characters that can't be part of standard R variable names with alternate text. The error handling in the tidyverse versions of these functions are substantially improved over the base R versions. If there's some piece of text in your file that doesn't quite fit the format, the tidyverse versions are much better at recovering from that. In terms of processing data, the tidyverse functions will always return text data in your file as text columns. The base R readers will sometimes convert those into factors, which can be confusing and particularly annoying. Likewise, the tidyverse versions of these functions are very good at importing date and time data, whereas with base R, you need a fair amount of additional work to correctly read in those data. R's data readers simplify the process of reading external data, but they're not going to eliminate all the work for you. You're still going to need to correctly determine the data format in order to select the correct reader. You might also need to provide additional information about the data in the file, particularly if there's portions of the file that need to be skipped prior to reading. You'll also need to check for errors in the resulting output tibble. These data readers aren't always perfect. Data files that you would receive aren't always perfect, and it's always good to go through your resulting data after it's read in to make sure everything was read in correctly. The specific information R needs when it reads in a data file varies by the type of file. So the next several videos are going to cover the various file readers as part of the tidyverse and other libraries for loading external data.